In today's video, I'm going to show you how you can make a simple but super sensitive non-contact AC voltage detecting device like you see right here. This AC voltage detector actually outperforms my more expensive TIF 300HV voltage detector. This is designed for use by linemen, and it's good up to around 110,000 volts. The circuit that I'm about to show you is more sensitive and only a fraction of the cost. Let's take a look at the schematic. The schematic that you're looking at I found at redcircuits.com. What I did is I modified the schematic shown at that website by removing the LED, which would start flashing when AC voltage is detected, and I replaced it with a piezo buzzer, in this case rated between 3 and 5 volts. You need a 4017, it's a decade counter. The 4017 has 10 different outputs, and you're only going to be using one of the outputs, and that's pin 3. Because the current output is so low on the 4017, you cannot trigger the piezo buzzer by connecting it directly to pin 3. So what I did is I took an enhancement mode field effect transistor, it's an N channel, a 2N7000 or a BS170 will work just fine, and I use the output from pin 3 to trigger the gate, which in turn turns on the piezo buzzer when AC voltage is being detected. I assembled the entire circuit on a PC board, a narrow one like you see right here, and mine uses a 3 volt 2016 button cell battery or a 2032, which is a little thicker and has a higher capacity. Right here is your normally open momentary push button switch, and across the battery, across the power rails, you have this 0.1 microfarad or a 104 capacitor, and that adds a little bit of stability across the power rails. The sensor wire is only around 2.5 inches long, like you see here, and it's 16 gauge wire. Pin 13, pin 15, and pin 8 are all connected together, and they go to the negative rail. So as you can see, it does not get much easier than that. I made the button cell holder using pieces of brass, bent it over, and you can see it's soldered there, the big brass tab, and the brass tab under the battery for the positive is soldered right here. The entire board is coated in E6000. It's a dielectric clear material, and it's nice so when I hold up my hand, if my hands are damp, it will not interfere with the circuit. To start it, you just simply point it where you want to go check for AC voltage, and then you push the button. I'm now going to give you a few demonstrations showing how well this AC voltage detector works. The first test will be the receptacle with nothing plugged into it. Push the button on the tester and then bring it close to the receptacle. Pretty good distance. Works very well. Now I'm going to plug in a cord. Now I'm going to show you how sensitive the tester is if you're testing power cords or Romex cables. This tester will tell you if the wire's live up to around 5 inches away. Check this out. Here we go. I'm far away. Look how far I'm going. Now I'm touching it. And now it stops. Super sensitive. Now I'm going to walk down my driveway, hold my hand in the air, and push the button as I'm walking under some high voltage power lines. Alright, you can see the power lines. There's the tester. I'm going to push the button on it. Then I'm going to walk towards the power lines. There you go. It's detecting them from right down here. Oh man, the ground is hot. Back up. There it is. It's back off. Let's go back again. And it's back on. It's pretty neat. It's amazingly sensitive. If you enjoyed this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlist as well. Thank you very much for watching.